Okay, goodbye. Today we are going to start with the study of gaseous equilibria. So move to the slide number 2. So today we are going to talk about those equilibria or those equilibrium reactions which involve the gaseous substances. So gaseous equilibria. Okay. So if we talk about the gaseous equilibria, so before talking about that how we can discuss about those equilibrium reactions which are involving the gaseous systems, we are going to talk about a term that is called as the partial pressure of gas. So goodbye, let me know that if we talk about a system, if I am drawing a vessel filled with the gas, this is suppose this is a container which is filled with gas and it is enclosed by the piston, and inside it we have gas filled, and I say that the pressure inside this one container is P. So can you tell me that how the pressure P is caused inside this gas filled container? Because of collision of particles with the wall. Very good, excellent. So pressure of gas is basically caused by the collision of gas molecules on the walls of the container. Okay, so this is the condition in which we have said that one gas is present in the system. So suppose I introduce another gas in this one system. That is just like I am introducing molecules of another gas, this one. So what do you expect? Whether the pressure in this one container it would increase or decrease? It would increase. It would increase. So suppose we say that P1 was the pressure of earlier system, and when we have introduced another gas, so pressure P2 has been added. So it means that, as you have said earlier, that the pressure inside a gas filled container is because of the collision of gas molecules on the walls of container. If you are increasing the number of moles of gas inside the system, the pressure inside the container it would increase. Goodbye the P1 and P2. In this one condition, just like I have written that P1 plus P2, this is the total pressure inside the container that can be represented as the PT. But what about these pressures P1 and P2? So what name would be given to these pressures? Do you know? Mass pressure. Yeah, very good, excellent. So these would be called as the partial pressure. So what is actually the partial pressure? It is the pressure exerted by a component gas in a mixture, right? So now we can write on the slide about this one. It is the pressure exerted by a component gas in a mixture. So it means that if you would increase the number of moles of gas inside the container, the total pressure would increase, and the pressure that is exerted by one gas in a mixture, that is the partial pressure of that gas. And if we talk about the total pressure, so total pressure of the gases present in a mixture is equal to the individual pressures called the partial pressures of the gases. Got it? Yes. Okay. So next one, we can now talk about that how we can use this concept of partial pressures to discuss about the equilibrium or the equilibria that are involving the gases, reactants and the products. So the next one thing is about the dealing with gaseous equilibrium. Okay. So it is said that if we talk about gaseous equilibria, we have to discuss about the gaseous equilibrium. So previously we have said that if we talk about the equilibria, or we have to discuss about any equilibrium system, so we use the terms equilibrium molar concentrations, right? But in the case of you can say that the systems which involve the gases, it is more convenient to talk about the pressure or the partial pressure instead of talking about the equilibrium or the molar concentration, right? So we can say that just like we have a reaction, we can, yeah, this is one of the good example of the gas phase equilibria. The N2 gas, when it reacts with 3 moles of hydrogen in the gas phase, it would give you the 2 moles of NH3. So this is a gas phase equilibrium. And if we talk about that, we have to discuss the position, or you can say that we have to discuss about the this one equilibria, that how much is N2 present at the equilibrium condition, how much is the H2, how much is the NH3 present in the equilibrium system. So whether we would talk in terms of the molar concentrations or another term or another quantity, so it is said that if we are talking about the gases, so it is more convenient and easy to talk about their partial pressures instead of talking about their molar concentration, right? So keep in mind that when we are going to discuss about the gas phase equilibria, they are discussed in terms of the partial pressures, instead they are discussed in terms of the molar concentration. Did you get it? Yeah. So if you're going to discuss about the, if you're going to write down the equilibrium constant expression in terms of the partial pressures, we can use the partial pressures in the same way, just like we have discussed previously, that when you are going to write the equilibrium constant expression, so the molar concentrations of products are written in the numerator, whereas the molar concentrations of the reactants are written in the denominator. The second one thing we have discussed, that all the molar concentrations of the products are multiplied together, all the molar concentrations of reactants are multiplied together, right? The third thing we have discussed, that the number of moles of any reactant or the product that is given in the stoichiometric or balanced chemical equation is written as a power in the equilibrium constant expression Kc, right? So these terms and these things would be kept when you are going to discuss the equilibrium constant you can say that when you're going to discuss the equilibrium constant expression in terms of the partial pressure, right? But still there are certain changes or certain differences when you are going to discuss about the equilibrium constant expression in terms of the partial pressure, and you are going to discuss about the equilibrium constant expression in terms of the molar concentration. Got it? So the first one thing is, as previously we have studied that for writing the molar concentrations, what is the notation? We basically use a square bracket, and inside that we write down the symbol of the chemical species. Whether we have just written, I have written A, it is a hypothetical chemical compound, it is not existing, but just for example, if A is the chemical compound involved in the equilibrium, so when when I'm going to write down the equilibrium, you can see that the molar concentration, then what I would do, I would put the square bracket, inside that I would put the symbol of the chemical species, and if I have any number of moles given in the stoichiometric equation, so I would write them as the power in the equilibrium constant expression in terms of the molar concentration, Kc. Got it? But when you are going to discuss about the use of partial pressures in the equilibrium constant expression, so what you would do, we basically use the letter P for the partial pressure, right? And the symbol for the chemical compound, whether it is a reactant or it is a product. First, I would write the uh, partial pressure notation for the nitrogen. So what you would do, basically you would put the symbol as the subscript with the letter P. So suppose it is N2, right? And there, and how many number of moles are involved in the balanced chemical equation for the nitrogen? One. So I would not write the power, right? In the same way, if you are going to write this one partial pressure representation for the hydrogen, so you would write the P. Along with that, you would write the hydrogen as a subscript, and if you have to represent the number of moles, so what you would do, you would here put 2. Sorry, no, not the 2, it's the 3. So why you have put the 3 in this one as a power on the partial pressure? Because the number of mass of hydrogen is 3. Yeah, in the balanced chemical equation it's 3. Okay, so now I want to write for the ammonia. So P NH3, and what would be the power? 2. 2, okay. Because 2 moles of ammonia are involved in the balanced chemical equation. Got it? Yes. Okay. So now move to the next one slide. So goodbye. If I want to write the equilibrium constant expression in the terms of partial pressure, so what I would do, I would write as the K. K stands for constant. So before that, let me know that we have for the earlier discussion we have written Kc. So what was the meaning of Kc? Equilibrium constant. Yeah. So equilibrium constant Kc. So equilibrium constant is given by K. What is the meaning of C? The same constant. No. It means that you are using the molar concentrations, right? So I have told you in the previous one lecture that K stand for the equilibrium constant and C stand for that you have used molar concentrations in the calculation of this constant. Got it? Yes. So now we would replace this one C, and what we would write? What do you expect what I would write? I would write B. B, okay, good. because now I'm using the partial pressures for the calculation of this one constant. Okay, so goodbye. Have a look at the previous one slide and let me know that how I would put the equilibrium, the partial pressures in this one KP.
So it will be Bn2 plus
No, goodbye. Why you are writing the reactants as the numerator? So write the products as the numerator.
Okay.
Hmm.
So it will be Bn2
NH3. No, not N2. First write down
plus a
about the
part of
products.
the numerator.
Hmm. So you have forgot about it. Okay.
No, but I just need to memorize it more and more.
Oh yeah. So you need to restart. Okay. It will take some time to
Yesterday, I
restart.
think because like yesterday I went to the barber and cut my hair, so
Hmm.
the information went to the hair.
Relatable. You have lost your hair, and along with that, you have also lost the knowledge of chemistry because that was there in the, you can say that in the base of hair. So when you have cut down the hair, so hair went away, and along with that, they have taken all the knowledge of chemistry.
Yes, but at least like on my hair now, look, I like handsome, more handsome.
Oh, you are preparing for Eid.
Yes,
Wow, very good. Okay. So goodbye. What is the power of this one partial pressure?
this one.
Goodbye. How it is one? Go to the previous one slide.
Yeah, this too.
Going to the barber has caused a lot of loss. Okay. Okay. So now let me know what I would write in the denominator.
It will be Bn2
Hmm. Okay. So
multiplied by B3H2.
P N2 and multiplied by P H2. Is it fine?
No,
Hmm. What should be added
it
more?
should be like 3
Hmm.
above the P.
Okay. So go by one more difference in the Kp and Kc expression is that for the Kp we write the square brackets, but for this one case we have not written the square brackets. Got it? So
Yes,
this is how you can discuss about the equilibria that are involving the gaseous reactants and the gaseous products. Got it? Okay. So goodbye. The one more thing that's very important as we are going to discuss about the Kp is the units of Kp. Okay. So if we want to discuss about,
although we talk about partial pressure in biology,
sorry,
I didn't understand that lesson.
which one?
Or partial pressure in biology, we took it, but I didn't understand the lesson.
Yeah, it would be just like diffusion.
I think yes for oxygen.
Yeah, it you are talking about the partial pressure in terms of breathing, how the
Yes,
oxygen moves from the alveoli into the blood, and how the carbon dioxide diffuses from the blood into the mm, lungs, alveoli, and then from alveoli it goes out with the air, right?
yes, I think there is a term called bore shift.
Mm, uh, in which one terms you are discussing?
Yes, for partial pressure of carbon dioxide.
Yeah, it is almost. I didn't remember the exact value about the partial pressure of the oxygen in the environment. I think so. One value is 116 mm of Hg, right? These values
I
just.
think like just we took it like as a graph to explain the graph and like to, for example, if the breathing increase, the
Hmm.
graph will become more stable.
Right, right. So it is about that. It would be just like that when you are doing the when you are going to the high altitude. So how the partial pressure of oxygen changes, because if you go high, then the partial pressure of the oxygen decreases, right? So
Yes,
just like it would tell you that how much efficient would be the process of breathing, and how you can find out how you can experience some difficulty in breathing at the high altitude, right? So I have got the idea you
but
are.
the breathing in a high altitude is so hard. Like before, like I think 1 year I was living in a place which
Hmm.
of high altitude because it is in the mountain. You
Hmm.
will always feel tired.
Yeah, this is because the partial pressure of oxygen is less. So less, you can say that amount of oxygen would go into your body, and you have to breathe with the difficulty because your body tissues and organs are always feeling the scarcity of oxygen. So that's why it is difficult to breathe and survive at the very high altitude.
The plus difficulty of breathing there is also the gravity because the mountain is going up and down,
Hmm.
so it's hard to walk.
Yeah, right, right. So even it is difficult to walk, and your body is also facing the deficiency of oxygen. So it is difficult to walk, difficult to survive there on the high altitude. So you must
Yes.
be using a pressurized cylinder there.
I think like it is available in many hospitals because there is many cases that experience deficiency
Hmm.
of
That is,
oxygen.
yeah, that is just like the ventilator. The highly pressurized cylinder is available for the patients which cannot breathe normally.
Yes,
Yeah, I have seen that instrument and that system installed with some patients.
but Mr. Are you a doctor?
No, I'm not a doctor, because but one or two time I have to go to the hospital with my grandma. She was going to have surgery, so that's why after the surgery she was put on the ventilator, and she was given the artificial breathing, because you know that during the operation or the surgery there is a lot of loss of blood, and after the operation it is difficult for a patient to survive on its own. So that's why the patients are given ventilator, and they are given the artificial breathing, and it
Hope,
may.
hope that she is well. But
No, no, mm, she survived for after the operation, but now she is no more. Just like before, I think so. 3 years back, she has gone to Allah Taala, right? Because she was quite
I
old.
hope that she entered Jannah.
Hmm?
I hope that she entered Jannah.
Yeah, inshallah. Surely she would be there in the Jannah. But she was suffering from, you can say that, surgery of the orthopedic surgery. And you know that orthopedic surgery is too much painful, and it is too much difficult. And it leads to a lot of blood loss, because it lasts very long. It approximately 1 or 2 hour long. So you can imagine that how much blood would be lost from the body of an old lady. So how she can survive after such great blood loss?
It is difficult to survive.
Yeah, it is surely difficult to survive. So there I have seen such kind of instrument which is used to give the artificial breathing. You may have even heard about that instrument, the ventilators during the age of the corona, that
Yes.
patients were shifted to the ventilators because they
Since that time was not very good because we have to see that from all of the day.
Right, right. So that was very, you can say that uh, a time period which was too much full of depression for particularly for the students because they have to
Yes,
sit at the home and they were far from their studies and everything was just like you can say that it has become stationary and stuck. So that was very difficult period for both the students and even for the teachers. It was too much difficult in that period of time. Okay, so goodbye. If we talk about the partial pressure, so we have to discuss about the units. So can you tell me that what is the unit of partial pressure? Do you know?
since centimeter per mole.
Uh, no. If we talk about the pressure unit, so you can tell me about the usual units of the pressure. What type of units are used in the discussion of pressure of gas?
Centimeter cube.
No, goodbye. It's the Pascal that is most of time
Yeah, the
used.
Pascal and or atmosphere.
Yeah, Pascal that is equivalent to the Newton per meter square. And along with that, one of the good unit of pressure that is used, that's the atmosphere, right? So partial pressure is also discussed in the same terms. So firstly, we would discuss about the partial pressure and the units of kp in terms of the Pascal, right? So if you want to write down the units for the kp, so you have to use the same strategy which we use for the finding out the units of the kc, right? So if we want to write the units for this kp, so what we can do, we have to put the units of the partial pressure of ammonia, partial pressure of nitrogen, partial pressure of hydrogen, right? So in the numerator you write Pascal and its cube. Oh, not the cube is a square. Okay. So then you would write in the denominator Pascal and multiplied by Pascal and its cube, right? Now you can simplify this one. This one
That will be Pascal minus 2.
Pascal square would be, you can say, cancelled out, and this would become Pascal square in the denominator. Then you can rearrange this one equation. Sorry, you can take the square of Pascal on the upper side of fraction, it would become Pascal raised to power minus 2. So this is the unit for the kp. Got it?
Yes.
Okay, good. So in the same way, if we have another gas phase equilibria, I'm writing its equation on the slide, and then we would discuss about its kp expression, and along with that we would write down the unit. So move to the next one slide. The equation is N2O4 irreversibly gives you 2NO2. So 2NO2, and both the substances are there in the gaseous phase. Okay, right. Okay, goodbye. So let me know that first I have to write the kp for this one. So how I would write the kp for this one?
So it will be N2 or no, I have to add B first.
Hmm.
Then N2 or 4. There is no square or M
No,
square.
goodbye. First write P, listen, PNO2 and then it's square. Your forgetting about this, you have to write the products always at the upper side of fraction or the numerator, and the reactants would be there in the denominator. Got it?
Yes.
Okay. So now I would write the P and N2 O4 and nothing in the power. Okay. So if I want to write the units for this one Kp, so unit, I would write Pascal, Pascal and square, and then Pascal. And the Pascal would be cancelled with this one square, and the unit of this one Kp, it would become the Pascal. Okay. One more equation can be written here. So H2 plus I2 gaseous and gaseous, it would give you the 2 hydrogen iodide in the gas phase. Okay. So if I want to write the Kp for this one, so I'm writing Kp for this one here. So let me know that how I can write the Kp expression.
That's to have the I B H I square.
Hi square. Okay, then
Divided by BH2 plus multiplied by BI2.
okay. So this is the Kp expression. And what about the units of this one?
They are not will cancel each other.
Yeah, no unit. Because if we put the Pascal square and divided by the Pascal into Pascal.
So it will be B square over B square, which is no unit.
Yeah. So this one square would be cancelled with both these terms, and this one Kp has no unit. So in the same way, just we have discussed for the Kc that Kc may have units, Kc may not have the units, and it depends upon the number of moles of reactants and the products. In the same way, the gas phase equilibria which are involving the equal number of moles on both sides of the equation, they would not be having any unit for this their Kp. Got it?
Yes.
Okay, very good. So the next one thing is goodbye. We have to discuss or use the Kp expression. Sometime we have to calculate the Kp, and we have to find out the partial pressures of some gases involved in the gas phase equilibria, just we have done for the previous one, just like the Kc expression. So now move to the next one slide. So this gas phase equilibria is given to you, and the equilibrium partial pressure at constant temperature are, you are given two values of the partial pressure, one for SO2 and you are given a value for O2, and along with that you are given the value for SO3. So all the partial pressures are given to you. Now we have to calculate the value of Kp for this reaction. So how we can do it? It is quite easy to do it. First we have to write down the Kp for this one reaction. So help me to write the Kp.
So it will be BSO3 square.
Good. Okay.
Then divided by BSO2 square.
PSO2 square and multiplied
Plus
by
multiplied by BO2.
O2. Right. So the next one step is we have to put the values for this one. So Kp is equal to let me know how we can put the values. So SO3 8 into 10 to the power 6 Pascal,
Yes, B square.
and the square of this one. Then you have to divide it with the 1 into
One time, so it is 1 million Pascal.
10 to the power 6. This is for SO2, and it would be squared.
Yes.
And then you have to write for the 7 into 10 to the power 6. Okay. So goodbye. Do the calculations and let me know the answer. Goodbye. You have to do this calculation separately. First, take the 8 into 10 to the power 6 square, and then note down the value, and then divide it. Then do 1 into 10 to the power 6 square, then multiply it with the 7 into 10 to the power 6, and then divide them together, right?
Okay. The answer is 9.14.
9 point.
14.
Okay, 1 4. And what is the power with the fact this one value?
Minus 6.
Hmm,
10 minus 6.
10 to raise power minus 6. Okay. So goodbye. What is the unit for this one? Kp.
There is Pascal minus 1.
Right. Very good. So it is Pascal raised to power minus 1. So this is how we can use the partial pressures in order to study the gaseous equilibria. We can find out the value of Kp by using these partial pressures, and the way we have discussed or used the Kc for any liquid phase equilibria, we can use the Kp for the gas phase equilibria. Got it?
Yes.
Okay.